Ever wondered why your phone's AI recognizes your voice, but saps the battery so fast? Or why self-driving cars require supercomputers to process sensory data in real time? The answer lies in how we design artificial brains, and a groundbreaking innovation might be rewriting the rules. Let's break it down. Artificial neural networks, ANNs, the engines behind today's AI, simulate the brain by processing data through layers of interconnected nodes. But here's the catch: they're energy-intensive. Training a single model can consume as much electricity as a small town. And traditional hardware like GPUs and TPUs, they're optimized for massive parallel computations, not the sparse, event-driven signaling of biological neurons. Enter spiking neural networks, SNN, a brain-inspired alternative. Unlike ANNs, which constantly process data, SNNs use spikes, or discrete binary signals, to transmit information, much like real neurons fire in response to stimuli. This sparsity makes them vastly more energy efficient. But there's a hurdle. Existing hardware isn't built for this kind of low-intensity, event-driven computation. GPUs struggle with their own bandwidth limitations, while neuromorphic chips, though efficient, are rigid and difficult to program. So how do we bridge this gap? A team at the University of Sussex has developed FeNN, a RISC-V-based processor tailored for SNNs. Think of it as a flexible, programmable brain-on-a-chip, implemented on FPGAs, reconfigurable hardware you might already use in smart home devices. Here's the breakthrough. FeNN employs stochastic rounding, a technique that maintains precision without demanding massive computational resources. It's like using a compact calculator instead of a supercomputer, still accurate, but exponentially more efficient. In benchmarks, FeNN outperformed embedded GPUs and Intel's Loihi neuromorphic chip, classifying spoken digits in half the time and with half the energy. Why does this matter? Imagine AI that's not just powerful, but sustainable and adaptable. FeNN architecture scales seamlessly from edge devices like smartwatches to cloud servers, slashing energy use without sacrificing performance. It's a critical step toward AI systems that mimic the brain's efficiency, rather than relying on brute force silicon. Next time you interact with AI, remember, the future might be powered by spiking neurons, not just circuits. And with FeNN, that future is already running on a chip. Stay curious and let's keep building smarter, because the next revolution isn't just about speed. It's about efficiency.